Hey there, so I wanted to do a quick example from your homework of how you can graph a polynomial by recognizing the end behavior, the zeros of the function, their multiplicities. So let's get started. Suppose you have f of x equals negative parentheses x plus 1 squared times x minus 2 squared. So first we notice this is a polynomial. And to figure out its end behavior, we use two things. For end behavior, we need to recognize what is our degree. Let me grab a color here that you can see. What is our degree? And in this case, to find the degree, since we're in factored form, we would take the power of this factor, which is a 2, and the power of this other factor, which is a 2, and we'd add them up. 2 plus 2 is 4. Now 4 is even, which means that at the extremes, we're going to be going in the same direction. So either they're both going to go up or they're both going to go down. So to determine which of those it is, we then look at the sign of the leading coefficient. What is our leading coefficient going to be if we were to expand all of this? We don't have to, but let's just look at what would happen. Here we have 1x and 1x. Eventually, when you square each binomial, you'll get an x squared and an x squared term, and a negative in front. You'll eventually get x to the 4th power when you multiply. So you'll have a negative 1x to the 4th power. In other words, this negative 1 in front is your leading coefficient. So if our leading coefficient is negative, because it's negative, and the degree of the polynomial is even, what we know then in this situation is that at the extremes, as x goes to the left forever, our graph should be going down forever. So it should look like this. For our end behavior, you can look in my notes and videos and you'll see that there's 4 categories. This is the situation when you have even degree and negative leading coefficient. Our end behavior at the extremes looks something like this. I believe in your homework it usually says falls to the left and falls to the right. So it's going down to the left and down to the right. If you take the future classes, you'll see that we usually write this as x goes towards negative infinity, f of x goes towards negative infinity. And as x goes towards positive infinity, f of x also goes towards negative infinity. Okay, so once we have the end behavior, we know what to do at the extremes. Great, so that's going to be very helpful for us. So falls to the left, falls to the right. But as far as using that to get our graph, we now need to focus on getting the zeros. Okay, the zeros, real zeros, are also known as x-intercepts. So if we're in factored form like we are here, we can simply look at each factor. This time there's no x in front, so there's no factor there other than the negative 1. So we don't have to worry about an x being 0 there or anything else. The only times that we'll get 0 in this function for an output is if the factor x plus 1 equals 0 or the factor x minus 2 equals 0. This comes from the factor theorem in the notes in the videos. So if you set each factor equal to 0, you'd get technically 2 copies of x plus 1, 2 copies of x minus 2. But all that means is that if x is negative 1, we have this factor turning into 0, don't we? Which means you square it, you still have 0, multiply it out, the whole thing is 0. So if x is negative 1, the output is 0. What about if x is 2 here? Yeah, if x equals 2, that creates this factor to become a 0. Squaring it, that's still 0. 0 times anything is 0. So the output is 0 when x equals either one of these numbers, which means I really have x-intercepts. That's when our y output would be 0. So I could go to my graph, and at negative 1 and at positive 2, I'm going to put my x-intercepts on the graph. Okay? So those are my 2 x-intercepts. Now what happens there is going to depend on the multiplicity. What I mean by multiplicity, again, if you look in the notes and videos, you'll see that the multiplicity is the power of each factor. So this real 0, negative 1 came from the factor x plus 1, whose power was 2. So he had a multiplicity of 2. And x equals 2, this real 0 came from its factor, x minus 2, whose multiplicity, the number of times it's repeated, is 2. So those are both multiplicity 2. With multiplicity 2, which is even, we know that at those locations, the graph will touch and turn around or bounce off of the x-intercept. It will not cross through the x-axis. So we will be touching and touching, but not crossing at these locations. Okay, so we know that now. What else can we determine from this? Well, we can now draw our sketch, a very basic sketch so far. What do I mean? I know that at the extremes, so at this x-intercept on the left, as I go toward the left forever, my end behavior says I should be falling forever. So -1, left of that, I should be falling forever. Similarly, at 2, that's the most right x-intercept that I have, I should be going to the right and down forever. I should be falling toward the right. So something like this is happening. I know that. But what else do I know? I know that at -1, I touch the x-intercept and turn around. So notice I do not cross through. I don't change from negative to positive. I stay below the x-axis there. I hit it and I turn around. Similarly, before 2, I should be hitting it and turning around. And that's because the multiplicities are both even. That's why we touched. Because it was even here and even here, we touch and turn around. So the only thing that really I'm missing now to finish a good sketch here is the y-intercept. So how do I find y-intercept? We remember x-intercept was letting your output equal 0, which really meant each factor was 0. But in finding the y-intercept, we need to let x equal 0. And to let x equal 0 here is like f of 0, so let's work that out. That would mean -1 or -0 plus 1 getting squared times 0 minus 2 getting squared, which ends up here as negative parentheses 1 squared, -2 in parentheses squared. So in reality, I have a negative, use your PEMDAS, 1 squared is 1, -2 times -2 is 4 positive. So we should be getting that our y-intercept is negative what number? -4, that's right. So that's my only y-intercept. You could write that as the point when x is 0, y is -4. Same thing, right? That's the y-intercept there. So in my graph, 1, 2, 3, 4, down here, 4 below, I now know that my y-intercept is located when x is 0, y is -4. So I can now draw my sketch a little bit cleaner. I'm going to get my pink marker again. And now I know that after I hit -1, it starts falling until I hit -4. It has to go through there and turn around so that I can end up hitting 2 as my other x-intercept. That's what we mean by a sketch of the polynomial. So we were able to draw a sketch of the polynomial by using the end behavior, which I found using the degree being even and a leading coefficient being negative. That meant I go down or I fall in both cases at the extremes. I found my real zeros by letting each factor equal 0. That was -1 and 2 as my real zeros, so I put those on my graph. I noticed their multiplicities were both even. The factors of each of those had a power of 2, so we said we would touch, not cross, touch, and turn around. So I touch and turn around, touch and turn around. And finally, to get a better sketch, we needed to know when I'd cross the y-axis. So to find the y-intercept, I needed to let x equal 0 in the function. So let your input be 0 and see what happens carefully with your arithmetic. So following PEMDAS, we ended up getting -4 there. Okay, I hope this helped. If not, let me know and I'll see what else I can do for you. Have a great day and happy practicing, because remember, math is not a spectator sport.